Assalamualaikum warahmatullahi wabarakatuh. Hi everyone. This project is by Section 5 Group 1 under Dr. Bazil Anak Lelaki David Daniel. Today, we want to present about noise emitted by vehicles in decibels at Persiaran Tunggal Fababa near the UTHM Library. This is our group member. I'm Hani Sufina. And another my team is Nur Iza Safia, Nur Atika Alia, and Awada.
Assalamualaikum and good day. My name is Awada and today I will be presenting our group project on traffic noise near the UTHM Library. For problem statement, traffic noise is a growing environmental concern, especially in areas with high vehicle movement. Noise from cars and motorcycles can affect comfort, concentration and the quality of learning environment. Persiaran Tunggal Fababa, located near the UTHM Library, experiences continuous traffic flow throughout the day. However, there is limited data on the actual noise level produced by vehicle at this location, and it is unclear whether the noise complies with the allowable limit of 60 decibels. Therefore, a statistical study is needed to assess and analyze traffic noise in this area. Next, for the objective of this study are first to measure and analyze the noise level emitted by vehicles, second to compare the noise emission between motorcycle and cars, and third to determine whether the average vehicle noise level is below the allowable limit of 60 dB.
For this part, I will explain our data collection method. We use a field measurement method to measure traffic noise at Persiaran Tunggal Fababa near the UTHM Library. The noise level we are measured in decibels and the data was collected over 2 days. In total, we record 200 vehicles which include 100 cars and 100 motorcycles. All measurements were taken under similar environmental conditions to keep the data consistent. After that, we analyzed the data using statistical method to study the variation in traffic noise.
Hello everyone, this is the overview for the project. First, we identify the variable, the noise emitted by vehicles for cars and motorcycles. Next, we collect the data at Persiaran Tunggal Fababa near UTHM Library for 2 days and we present the data. After the data collected, we do the calculation data for mean, mode, variance, and also standard deviation. Lastly, we do the data analysis by finding the probability, inferential statistic, and also hypothesis testing.
Starting with our raw data presentation, we have collected 100 individual noise level readings for both cars and motorcycles measured in decibels. This dataset serves as the foundation for our comparative analysis, allowing us to see the distribution of noise across a variety of vehicle samples. To make sense of the raw data, we organize the readings into discrete time class. For car, the noise level range from 40 dB to 79 dB, with the highest concentration of vehicle 50 in total, falling into the 65 until 96 dB range. For motorcycle, the range is tighter, starting at 50 dB and reach 79 dB. Here, the most frequent readings occur in the 60 until 64 dB category, representing 47 to the 100 sample. Now, let's look at the mathematical breakdown for car. The mean noise level for car is 62.97 dB with a mode of 66.47 dB and a median of 65.8 dB. To understand the spread of this data, we calculate a variance of 2845.62 and a standard deviation of 53.34 dB, indicate significant variability in how much noise different cars emit. Finally, looking at the statistic for motorcycle, we see a slightly higher mean of 63.95 dB. The mode is 62.89 dB and the median is 63.54 dB, showing that these three measures of central tendency are very close group. Notably, The standard deviation for motorcycle is 42.8 dB, which is lower than that of cars, confirming that motorcycle noise level is in this study we are more uniform. When we visualize this data through histogram and frequency curve, we can clearly see the distribution patterns. The graph for car show a peak at the higher ends of its range, indicate that while car can be quick, that frequently reach higher decibel levels. In contrast, the motorcycle graph show a more centralized peak, suggesting a more consistent noise output across the sample size.
This slide shows the probability analysis of cars. On the left side, we have a group frequency table showing time classes, frequencies, and their corresponding probabilities. The total number of observations is 100, so each probability is calculated by dividing the frequency by 100. For example, the time class 65 till to 69 has the highest frequency, which means it also has the highest probability. On the right side, we present the cumulative distribution function. The distribution function the shows the probability that the number of cars is less than or equals to a certain value. As the value of x increases, the cumulative probability increases until it reaches 1. In conclusion, this slide explains how car data is converted into probabilities and used to construct the cumulative distribution function. This slide shows the probability analysis of motorcycle. On the left side, we have a frequency distribution table for motorcycle based on time classes. The total number of observation is also 100, so the probability of each class is calculated by dividing the frequency by 100. For example, the time class 60 to 64 has the highest frequency of 47, giving a probability of 0.47. This indicates that the most motorcycles falls within the time range. On the right side, we show the cumulative distribution function. The cumulative distribution function represents the probability that the number of motorcycles is less than or equal to a given value. In summary, this slide demonstrates how motorcycle data is transformed into probabilities and then used to build the cumulative distribution function.
Here is the data for inferential statistics. So we need to calculate the total number of frequency, total number divided by total frequency, and also x squared, cars, and also motorcycles. On the right side, we have the calculation of mean for motorcycles and also cars. For this inferential statistic, we will use the significant level of 0.05. The degree of freedom for numerator is k minus 1, which is the value of k is 2, because we have two categories, which is cars and motorcycles. For denominator, we will use the formula of n minus k, which is the value of n is 200, the total number of samples. For the rejection criteria, if the calculated F is bigger than F critical, we will reject HO. Here is the one-way ANOVA test, where we assume that HO, the mean noise levels emitted by cars and motorcycles, are equal. HA, the mean noise levels emitted by cars and motorcycles, are not equal. As previously mentioned, we will use the significant level of 0.05, the degree of freedom for numerator, k minus 1, the value of k is 2 because we have two categories, cars and motorcycles. And for denominator, we will use n minus k, which is the value of n is 200, the total of sample number. On the right side, this is the calculation to find the